All right, this video is for the Proving Triangle Congruence notes. This is going to be lesson 4.9. So, triangle congruence. Triangles whose corresponding side lengths and corresponding angle measures are equal. All right, and then we've got this little acronym down here, and this stands for corresponding parts of congruent triangles are congruent, meaning they're the same. Okay, so first up, I may need to zoom out a little bit here so we can see all of this. So let's see here. Zoom out a little bit. Still doesn't help us much. Try one more time here. Okay. All right, so side angle side. Given C is the midpoint of AD, and BE. Prove that angle A is congruent to angle D. Okay, so what we would do for this one is we'd look through the pieces. So this is a proof table. Normally you fill these out, it's a lot of writing. So C is the midpoint of AD and BE. That's given to us. So that means that BC is congruent to EC. If that's the midpoint, then this piece and this piece are congruent. Same with AC and DC. These two pieces would be congruent. And then angle ACB and angle DCE. So ACB, that's this angle. DCE, that's this angle. Those are congruent because they're vertical angles. Okay, so remember when we have that kind of hourglass shape, we have vertical angles. So now what we have is side, angle, side congruency. Okay, all we have to do is prove that the triangles are congruent. Once we do that, then automatically A has to be congruent to D. So again, here's where that order really comes into play. If I wanted to name these triangles and I wanted to write a congruency statement, triangle A, let's do ABC. ABC is congruent with, okay, A to B is this blank side, and then we go to the side with a 1. So for it to match up, we would have to go D, E, C. D, E, C. Because right here, B and C have to be in the same location as C and E. B and C, C and E, they're both at the end. A and C, first and last. D and C, first and last. So that name is really, really important when we're naming these congruent triangles. All right, angle side angles. So given BC is parallel to AD. BC is parallel to AD. And AB is parallel to DC. Prove that AD is congruent with BC. Okay, so for this one, sorry guys, my notes are kind of in a weird spot here. All right, so here's what we're given. BC is parallel to AD. So that means angle BAC is congruent to DCA. That's this one. Because alternate interior angles are congruent. So when we have parallel lines, BC and AD, so let's look at just those pieces. BC, AD, and then we're going to say that this line here, okay, that's this. sorry, I'm trying to think about how I want to represent this to make sure I'm representing it right. Means this angle here and this angle here, those are alternate interior angles, and those are congruent. Okay? So then BCA, so that's this one, and DAC, that's this one. Those are alternate interior angles as well. So again, if we look at it as two parallel lines with a transversal, like this line is continuing onward, and these sides continue onward, we can see those relationships a little bit better. So we know these two angles are congruent, these two angles are congruent. AC equals AC. That means this side of the triangle. So if we look at it just as a triangle, ABC, and then just as this triangle, ADC. They both have this side in common because they're the same side, and that's using the reflective property. So what that means is we have angle, side, angle congruency. Okay? So if we can prove that the triangles are congruent, it automatically proves that AD and BC measure the same thing. Again, naming these. So say I want to go from the 1 mark to the 2 mark to the no mark. CAD. That would be triangle CAD. So from the 1 mark, A, to the 2 mark, C, to the no mark, B. That's the congruency statement. Again, order. A and D have to be in the same spot as B and C. And they are. They're both at the ends of their names. All right. Angle, side. So given AB is perpendicular, so that's what that one means, to BC. AB is perpendicular to BC. And CD is perpendicular to BC. And angle A and angle D are congruent. That means this angle and this angle match. Prove that they're congruent. So we know this side matches, and we know these are perpendicular. So if these are perpendicular, that means this is a 90-degree angle, and this is a 90-degree angle, and then we have this matching side. Okay? So if I wanted to name these, angle, angle, side, right? So angle, triangle D, 90-degree angle, and then the matching side would take us to B, is congruent with, so look what I started with, the single angle. So I have to start with the single angle over here, A. Then I went to the 90-degree, so then B, and then C. That order is really important. All those pieces have to match up in that order. All right, hypotenuse leg. Is this our last one that we have? No, I think we've got one more. Okay. So given triangle LMN is an isosceles triangle. LMN is isosceles with vertex angle M. MP is an altitude, okay, of that triangle. Prove that LMP is congruent with NMP. Okay, so what we know, if this is an altitude, we know that LPM is a 90-degree angle, and that NPM is a 90-degree angle. Okay? Definition of altitude, perpendicular lines. That's how we know that, those definitions. So LPM is a right triangle with hypotenuse LM. NPM is a right triangle with hypotenuse NM. So that's the definition of right triangles. So the definition of an isosceles triangle is two sides have to be the same. So if these are both the hypotenuse, then this side has to measure the same as this side. That's the definition of an isosceles triangle. And MP, this side, is going to be the same for both triangles. That's the reflexive property. They share that side. So now we have the hypotenuse leg. We've got a right angle. They have the same hypotenuse, and they have a same leg. And that proves that these two triangles are congruent. All right, and then finally, hopefully this is finally. Yes, this is finally. Side, side, side. PQR has vertices, so we are going to have to graph this at 2, 5. 2, 1, 2, 3, 4, 5. So that's P. And then 5, 2, that's Q. And then 1, 1, that's R. Okay. There's PQR. GHI has vertices at -4, +4. So that's G. H is -7, +1. That's H. I is at -3, 0. That's I. All right. It says plot each triangle, so we did that, and determine if they're congruent. So what we can do is we can use the distance formula. So that's a lot of work. We're just going to do it a couple times on this one. So we're going to do HG. So remember distance formula is x2 minus x1 squared plus y2 minus y1 squared. So let's do HG, right? Here's G and H. Here's my values. So I would have -7, right, minus a -4 squared plus 1 minus 4 squared. What that ends up giving me is the square root of 18. If you would type just this piece in your calculator, you're going to get an 18. And then 18 will simplify to 3 times the square root of 2. Okay? If we do QP, Q, and then here's P. So 5 minus 2 squared plus 2 minus 5 squared would give me the square root of 18, or 3 times the square root of 2, meaning these two sides measure the same thing. We could go down and we could do that with the rest of these. Instead of doing the math, I'm just going to tell you, if you use the distance formula, GI is the square root of 17, PR is the square root of 17, HI is the square root of 17, and QR is the square root of 17. Which means all 3 sides of this one match all 3 sides of this one. Corresponding sides are congruent, therefore by side, side, side postulate, triangle PQR is congruent to triangle GHI. The side that has to match up there, H and G, Q and P. Q and P, H and G. That side has to match up. So that's it for this set of notes.